Hi, it's Mrs. Murray, and I'm going to go over tonight's homework. So today we were looking at dividing out factors of polynomials to eventually be able to write the entire polynomial as an equation in factored form. So for number one, for this polynomial function, p of x equals x to the third minus 3x squared minus 10x plus 24. If we know that x minus 4 is a factor of that, then we can divide it out. And then once we divide it out, we'll have a quadratic, and we know how to factor quadratics. So then we can continue factoring and eventually have the entire polynomial in factored form. So since this is a third degree polynomial, I would expect to be able to write it as the product of three factors. So I'll set up the box that we used in class today. And so I may have made this a tiny bit too small, but I'll do my best. Here we go. Okay, and so I'm dividing by x minus 4. So x goes here, negative 4 goes here. And then my first term from the polynomial x to the third goes right here. And now I think about, okay, what values of are going to go up across the top? So my first target is, what do I multiply the x by to get x to the third? And I multiply by x squared. And so x squared times negative 4 is negative 4x squared. And that's what goes down there. And then I need negative 4x squared and something else to add up to negative 3x squared. So to get a negative 3x squared, the box diagonal from it needs to be x squared, because then I would have those two would add up to negative 3x squared. And so now what do I multiply x by to get x squared? And I multiply it by x. And so now x times negative 4 gives me negative 4x. So then my next target is the negative 10x. What do I multiply, or what do I have to add to negative 4x to get negative 10x? I have to add negative 6x. And then above that, what would I have had to multiply x by to get negative 6x? I would have had to multiply it by negative 6. And then our final check is below the negative 6x is where I put the answer to negative 6 times negative 4. That is 24, which is what it's supposed to be, and so we've done it correctly. So now I'm at the point where I know that the original equation p of x is equal to x minus 4 times x squared plus x minus 6. So now I want to take the second part, the quadratic, and see if I can factor it further. So I'm looking for factors of negative 6 x squared that add up to x. So I know I could do negative 1x times 6x. That's too big. Negative 2x times 3x. Well, when I multiply those together, I get negative 6x squared. And when I add them together, I get x. So this is my factor, negative 2x times 3x. And so I should have made the box to begin with. I'm sorry about that. Okay. And then that first GCF between x squared and negative 2x, the GCF is just x. X times x gives me the x squared. I need a 3 here to get the 3x. I need a negative 2 here to get the negative 2x, and then negative 2 times 3 is negative 6. So that works out. So my final answer for A is P of x equals the x minus 4 that I originally divided out times the other two factors, x minus 2 times x plus 3. Part B is just asking to draw a rough sketch of the function. And so I'll draw some axes. And then I know my x-intercepts are 4, 2, and negative 3. And I know the y-intercept is what I get when I put zeros in for x. So the y-intercept is 0 minus 4 is negative 4 times 0 minus 2 times 0 plus 3. That's positive 24 altogether. Okay, so here's, I'm just kind of making this up. I'll say that's 24. And then my x-intercepts, let's see, maybe put some little points on here. So this is negative 3. And I didn't make that axis quite large enough. So I'll just continue it here. And so then I've got positive 2, 1, 2, and 3, 4. This is an odd positive polynomial because the degree is 3 and the leading term is positive. So it's going to have this kind of end behavior. Okay, so I'm going to start up here at this y-intercept. It's going to go down that way. And then from the y-intercept down through 2, and then turn around and go back up through 4. Okay, so my scale is, different on the x than it is on the y, which is why it looks so wide, but that's a general idea of what it will look like. Number 2 says, Tyler thinks he knows one of the linear factors of P of x equals x to the third minus 9x squared plus 23x minus 15. After finding that P of 1 equals 0, he suspects that x minus 1 is a factor of P of x. Here's the diagram he made to check if he's right, but he set it up incorrectly. What went wrong? So if he knows this is true, then he should divide out this factor. And when he put it here, he's actually dividing by x plus 1 rather than x minus 1. So there should be a negative right there. And that's what he did wrong. Number 3 is a pretty long problem because we have to do a couple of things. So it tells us two known factors are x minus 2 and x plus 1. And then we want to know which of these functions, all the way in factored form, will represent this polynomial here. And so we're going to actually have to divide out those factors, each of them, and then factor what's left. Okay, so I'm going to first divide out the x minus 2, but I'm going to start my answer. I'm going to start my answer down here and say Q of x equals x minus 2 times x plus 1. And then the rest of the work that I do is going to be to find the other two. So it's a fourth degree polynomial, right? Fourth degree polynomial. And so we would expect to be able to find 4 linear factors. And right now we have 2. Okay, so let's divide out the x minus 2. So I'm going to, let's see here. Need a box like this. I need a column for x minus 2. I need a row for the new polynomial. I need 2 rows here. So we have x and negative 2. And then what I'm dividing into has 1, 2, 3, 4, 5 terms, which means I need 4 columns for that part. That was the mistake I made when I was making number 1. When I was making number 1, I just was thinking I needed as many columns as terms, but it's actually 1 less. Okay, so 2x to the 4th goes here. And so I'm going to start that process again, what we did in the last one. Okay, so my target is 2x to the 4th, and that means x was multiplied by 2x to the 3rd. Now I multiply that 2x to the 3rd by negative 2, and that gives me negative 4x to the 3rd. My next target is negative 9x to the 3rd. Negative, oopsies. Uh-oh, I did something funny. Okay, there we go. So my next target is negative 9x to the 3rd. And so right here, I want it, there we go. Negative 9x to the 3rd is my next target. That means the negative 4x to the 3rd has to be added to negative 5x to the 3rd. So it adds up to the negative 9x to the 3rd altogether. And so above that, I'm going to put a negative 5x squared, because that times x gives us the negative 5x to the 3rd. Negative 5x squared times negative 2 gives us 10x squared. And our next target after that is negative 12x squared right here. Okay, so to get a negative 12x squared, this has to be negative 22x squared, so that when they get added together, we get the negative 12x squared. Okay, and so in order for that to happen, you guessed it, there has to be a negative 22x up here. And then negative 22x times negative 2 is 44x. Our next target is 29x. And so I need to add a negative 15x to 44x to get 29x. And so above the negative 15x, we need a negative 15. And negative 15 times negative 2 is 30, which was the target, so that works. Okay, so now, you guys, I'm going to have to do some division again, but this time, this polynomial is my target, and I'm dividing by x plus 1. Okay, so that polynomial has 3 terms, which means that when I make the little box, I need a row for my new answer. I need a column for the x plus 1, another row to separate the x and the positive 1. My initial target is 2x to the 3rd. And then I just need 3 columns here. Okay? So my initial target, like I just said, is 2x to the 3rd. And so x times 2x squared is 2x to the 3rd. And 2x squared times 1 is 2x squared. And then, so I got my first target. My next target is negative 5x squared. In order to get negative 5x squared, this had to be negative 7x squared because it's going to add to the 2x squared to get negative 5x squared. Okay, and so x times negative 7x is negative 7x squared, and negative 7x times 1 is negative 7x. My next target is negative 22x. And that means I have to combine negative 7x with negative 15x. And to get that to be a negative 15x, there must have been a negative 15 right here, because negative 15 times x is negative 15x. And then my target is also negative 15. So you can see when I put the negative 15 here, negative 15 times 1, that I got the target in one step. Okay. So we've actually just verified that the two known factors are actually factors. And now we're ready to factor what we have left and finish this super long problem. So we are now going to factor this polynomial. Okay, so 2x squared minus 7x minus 15. And one more factor box. So first term goes here, last term goes here, and then we have to figure out, multiply those together. What multiplies to negative 30x squared and adds to negative 7x. And so 1x times negative 30x, that doesn't work. 2x times negative 15x, that's getting closer, but it still doesn't quite get to negative 7x. However, 3x times negative 10x, that adds up to negative 7x. So I'll put a 3x here and a negative 10x here, and then I'll continue factoring. The GCF of the top is just x, and then I need a 2x here. And then 2x times negative 5 is negative 10x squared. Above the 3x, we need a 3, because 3 times x is 3x. And then just double check, 3 times negative 5 is negative 15. So that means that the rest of the factors are x minus 5 and 2x plus 3. And I didn't quite give myself enough room, so I'm going to just kind of finish it down here. So q of x equals x minus 2 times x plus 1 times x minus 5 times 2x plus 3. And holy smokes, that was the longest problem ever. So when we look at our answer choices, it looks like answer choice B is the one that matches up with all of that work. Okay, so good news. I said you could skip 4, so we're just going to move right along. The last couple of problems aren't as much work. They're kind of like the dessert after we ate all the vegetables. Okay, so for the number 5, state the degree and end behavior. So remember, for degree of a polynomial, you're looking for the term that has the highest power of the variable. And that term is 4x to the third. So that means the degree is equal to 3. Which is odd. And the leading term is 4x to the third, which is positive. And remember, odd, positive, and behavior looks like this. And so you would write out, as x gets larger in the negative direction, y gets larger in the negative direction. As x gets larger in the positive direction, y gets larger in the positive direction. Number 6 is a similar problem. It says describe the end behavior of f of x, which equals 1 plus 7x plus 9x to the third plus 6x to the fourth minus 2x to the fifth. Again, we're just looking for the term that has the largest power of x, which is the last one. And so this time the degree is 5, which is also odd. But the leading term is negative 2x to the fifth. So instead of odd positive, this is odd negative. Odd negative polynomials have end behavior that looks like this. And so we say, as x increases in the negative direction, y increases in the positive direction. And as x increases in the positive direction, y increases in the negative direction. And then the last problem here, I suggested on the answer key that you use Desmos to solve this, but you could also multiply them out. So multiplying out and then, solve it algebraically. They don't have a common factor, so the method from last week where you pull out the common factor would not be an appropriate method for this problem. So I'm going to multiply out x plus 3 times x minus 1 and x plus 1 times x minus 3. And when I multiply up here, I get x squared negative x 3x negative 3. So combining the 3x and the negative x and writing it out in standard form, x squared plus 2x minus 3. That equals, if we're going to solve for points of intersection, then that means the functions are equal to each other. So I'm going to multiply out the other side and put it in standard form. Okay. And so again, I'm going to add together the like terms that are on that diagonal. And so we have x squared, and then negative 3x plus x is negative 2x, and then minus 3. So I notice right now, and you may notice this as well, that they have the same y-intercept because the constant when written in standard form is the y-intercept. The y-intercept is when x is 0. So for both of these functions, when x is 0, y is negative 3. So I know that's one solution. Not quite sure if it's the only one, but I'll continue solving and figure it out. And so when you're solving a quadratic, whether you're going to factor or use the quadratic formula, you need one side of the equation to equal 0. So to get the right side of the equation to equal 0, we are going to subtract the x squared and also subtract it over here. We're going to add the 2x and also add it over here. And we are going to add the 3 and add it over here. So you can see those are all equal to 0. And then on this side of the equation, x squared minus x squared is 0. 2x plus 2x is 4x. Negative 3 plus 3 is 0. So we're solving 4x equals 0. And we get x equals 0, which is what I initially thought. And then you can, if you want to, you can still plug that 0 into either f of x or g of x to get the y value, just to make sure it's negative 3. So I'm going to use g of x. 0 plus 1 is 1. 0 minus 3 is negative 3. And 1 times negative 3 is negative 3. So that is the one and only solution for number 7. So I hope that this was helpful for you. Make sure that you get your homework submitted in Canvas.